Okay. Because of net problem, we lost the net. So we'll start this example from same. So C2 of 0 becomes 0. C2 of 0 equal to 0 gives beta equal to 0 and C2 of t equal to 1 by 2 t into 2 to the power t. Okay. Thus u of t equal to C1 of ti plus C2 of t m1 into this u0. U0 is a column matrix alpha beta, and this is summation. This is what? Summation I from 0 to n minus 1. Now here n is 2. So 0 to n minus 1 means 0 to 1. And there you get C1 of t, Ci plus 1 of t into I plus C2 of t mi. Here. Ci plus 1 of t into mi. So Ci plus 1 of t is, if I put I equal to 0, you will get firstly C1 of t. You will get C1 of t there. Okay, that is the case there. C1 of t into m0 plus C I is equal to 1, C2 of t into m1, C2 of t into m1. There you get C1 of t into m0 is I, C2 of t into m1 into initial factor alpha beta. So C1 of t is 2 to the power t into identity matrix plus C2 of t is t into 2 to the power t minus 1 into this is m1 and into alpha beta. So if I solve this one, 2 to the power t, here you can take 1 by 2 and you can write here 2 to the power t, isn't it? So 2 to the power t can be taken common, 1 plus t into minus 1 by 2, that is minus t by 2, 1 minus t by 2, 0 plus t into 1 by 2, that is only t by 2, 0 plus t into minus 1 by 2, that is minus 1 t by 2, and 1 plus t into 1 by 2, that is 1 plus t by 2 alpha beta. Okay, this one is the ut. This one is the ut. Okay, so by using same algorithm, we can solve some remaining examples also. Only alpha and beta is here 2 and 1. All other terms are same. Here we have given, you find characteristic equation. So lambda 1 equal to 10, lambda 2 equal to 5 are the two eigenvalues. M0 is identity matrix, M1 is A minus lambda 1i, that is A minus 10i. You will get this one A minus 10i. Then C1t plus 1, C2t plus 1, lambda 1 0, 1 lambda 2, C1t, C2t. You solve these two. So you will get first order homogeneous equation. Use condition C1 at 0 equal to 1, C2 at 0 equal to 0. You solve them. You will get C1 of t is equal to 10 to the power t and C2 of t is equal to something like this. As second constant is 0, so we obtain the second constant as minus 1 by something is there. So 5 to the power t minus 1 is there. Okay, like that. Minus 115 is there, 5 to the power t minus 1. So you will get C2 of t as this one. So after finding C1t, C2t, put in this, you will get such type of relation there. Okay, that is the case. So many examples are there. You can go for these examples I have solved here. Even there is one example where we need not to go for the we need not to worry about Putzer algorithm. 2012, this can be written, compute all powers of a, 2002. So a is what? 2002 plus 0010. Now that is 2i plus 0010. This is your 2i. Now a to the power t becomes 2i plus 0010 to the power t. Since 0010 is the nilpotent, means and commutative with identity matrix, the binomial theorem gives a to the power 2 is equal to a to the power t is equal to this term to the power t plus nc1 means tc1 t into here 2i to the power t minus 1, that is 2 to the power t minus 1 into I into this second matrix, plus tc2, t into t minus 1 by 2 factorial, I to the power 2i to the power t minus 2 is there. You take from 1. Now 2i to the power t minus 1. So I into the power of this 1, 0, 0, 0, 0. It should be 2 to the power t minus 1. Here it should be 2 to the power t minus 2 into I. T into 2 t minus 1 upon 2 factorial into 2 to the power t minus 2 into I to the power t minus 2, it remains I, and only first power of this one, 0, 0, 1, 0. Okay, second power of 0, 0, 1, 0. So second power means this one, 0, 0, 1, 0 into 0, 0, 1, 0. If I take product, you will get first row, first column 0, first row, second column 0, second row, first column 0, second row, second column 0. We get null matrix. And all other powers are again 0. So I will drop this one, only you get these two terms, a to the power t. So 2 to the power t into identity matrix plus t into 2 to the power t minus 1 into 0, 0, 1, 0. And that can be written as 2 to the power t into 1 plus t into 2 to the power t minus 1 into 0. So only we get 2 to the power t. Second term, 2 to the power t into 0 plus this term into 0, we get 0. Third, 0 plus same term, t into 2 to the power t minus 1 and plus 2 to the power t into 1, that is 2 to the power t plus this term into 0, 0. So we get 2 to the power t. In this way also, we can compute the a to the power t. Not only in that, by using Putzer algorithm also, you can find a to the power t by finding its eigenvalues, and then a to the power t as c1 of t into m0 plus c2 of t into m1. You can obtain m0 and mn, c1t and c2t as in Putzer algorithm, and you can solve them. Okay, that was the first homogeneous equation. Now we can solve the non-homogeneous equation also. We can solve the non-homogeneous equation also. Okay, so if your system of this type u of t plus 1 equal to aut plus f of t, this term added here, non-homogeneity, satisfying the initial u at 0 equal to u0, and its a solution is given by ut equal to a to the power t into u0 plus summation from s is equal to 0 to t minus 1 a to the power t minus s minus 1 into f of s. Ut equal to a to the power t into u0 plus summation from s is equal to 0 to t minus 1 a to the power t minus s minus 1 into f of s. Okay, just I will verify it whether this satisfies this or not. So let ut is equal to this one, then u at 0, whether this condition is satisfied. See here, u at 0 equal to a to the power t into u0. So u at 0 means by putting t equal to 0, this becomes identity matrix into u0 plus summation s from 0 to minus 1 a to the power minus s minus 1 into f of s. But we know that if upper limit is smaller than lower limit, then this summation always equal to 0. So we get u at 0 equal to u0. So condition is satisfied. Now what about u at t plus 1? For t greater than or equal to 1, u at t plus 1 becomes a to the power t plus 1 u0 plus summation s from 0 to t a to the power t equal to t plus 1, t plus 1 minus s minus 1, that is t minus s into f of s. Okay, how you can write? This can be written as a into a to the power t into u0. We have written summation s from 0 to t minus 1. We take only the terms of t minus 1 up to t minus 1 first, a to the power t minus 1 a t minus s f of s plus by putting s is equal to t. If I put s is equal to t, last term becomes a to the power 0, that is identity matrix, into f of t. So we get only plus f of t there. Okay, so a into a to the power t into u0 as it is, plus I will take a outside, a into summation s from 0 to t minus 1 a to the power t minus s minus 1 into f of s plus f of t is there. So a into a to the power t into, you take a common from first two, a into a to the power t u0 plus summation s from 0 to t minus 1 a to the power t minus s minus 1 f of s. This is again a to ut. So a into ut plus f of t. So ut plus 1 equal to aut plus f of t, where ut is this one. So ut given by this is the solution of this non-homogeneous equation. Non-homogeneous equation. So ut given by 1 is the solution of given non-homogeneous system with given initial condition. We can solve the examples of non-homogeneous also. That is ut plus 1, 2, 2, 2 minus 1, ut u 0, 1, u at 0 equal to, this is the initial condition we have given. Here a is 2, 2, 2 minus 1. So a to the power t becomes. This a to the power t we obtain by using that Putzer algorithm. By using that Putzer algorithm. 4 by 5, 3 to the power t plus 1 by 5 minus 2 to the power t. I think you have solved this example here. 2, 2, 2 minus 1. Is it there? Yes. For this, we have already found a to the power t here. A to the power t is there. And that we have taken as it is there. Right? This one. So ut equal to a to the power t into u0 plus summation s from 0 to t minus 1 a to the power t minus s minus 1 f of s. Okay. So this is a to the power t into u0 0 0 10 summation s from 0 to t minus 1 of this. So first term is 0, no doubt first row, first column 0, second row, this one is 0. This whole 0, only we get summation s from 0 to t minus 1. Now first row, first column, 0 plus this term only. So 2 by 5 into this one. Second row, first column, this term becomes 0 plus only this term is there. So summation from s to 0 to t minus 1, this term and this term is there only. Okay. So this will be the solution of that non-homogeneous system. So in this case, we have seen how to solve homogeneous system and how to solve non-homogeneous system. Some other part we will take in next lecture.